Okay, like I said, guys, nothing this week as far as tests and quizzes go. We're going to do multiplying and dividing today. We're going to add and subtract Tuesday, Wednesday, and then we're going to work on complex fractions Thursday, Friday, I think. So, again, rationals is just fractions. Let's review for 1 second. If you had this, let's go back to middle school when you guys were multiplying and dividing fractions. If I had 1/2 times 3/4, how do you multiply fractions? Okay. Numerator times numerator, right? 1 times 3 would be 3. 2 times 4 is 8. And then we see if we can simplify, right? All right. So how about if I had 1/2 divided by 3/4? Can I just do the same thing? No. What do we have to do? Keep, change, flip. You keep the first fraction. We're going to change the sign to multiplication. And then I flip. This becomes 4/3. Now, guys, you can do this one of two ways. You can multiply numerator times numerator. 4 times 1 is 4. 2 times 3 is 6. And then what do we have to do? Simplify. So this becomes 2/3, right? What's another way we could do that? The simplifying inside the problem. You guys, this is called cross-canceling, right? Not cross multiplication. I know what you mean when you say that, but you can cross cancel right here. 2 goes into 2 once, 2 goes into 4 twice, and then you have 2/3 as your answer. Does everybody remember that? All right, so that same premise of multiplying and dividing fractions is exactly what we're going to do today. Tomorrow, we're going to start with grown-up fractions, rationals, where we have to get a like denominator, but that's not the case with multiplication and division. When you're multiplying, you can cancel out anything in the numerator and the denominator, whether it's on top of each other or like diagonal. In dividing, you have to keep, change, flip before you do. But the one most important thing that you have to remember to do, guys, is you're going to factor each part of the fraction first. Some of these problems you're going to end up factoring 4 times in one problem. You're going to factor the top left numerator, factor bottom right denominator, factor top right numerator, factor top bottom or bottom right denominator, and then cancel. It's all just a bunch of factoring. So we're just going to do 9 problems right now. I'm going to tell you how I think you should attack these. If you are not neat and organized, you could possibly make a lot of mistakes. The first thing you should do is notice the sign in the middle. What are you doing? Multiplying, so we don't have to keep, change, flip or anything. I'm going to go through and look at each part of my fraction. I start with the top left. There's nothing to factor out, so I'm just going to put it in parentheses. Bottom right, there's nothing to factor. I'm going to put it in parentheses. Bottom right here, so bottom left, bottom right, nothing to factor, correct? I do notice with x squared minus 9, what can I break that down into? X plus 3, good, and x minus 3. So now that you factor, this is gone. We don't have to look at it anymore. And now when you multiply, let's cross cancel. Let's cancel anything in the numerator and the denominator that is exactly the same. What can I cross out?
X plus 3.
Okay, I have an x plus 3 on top and an x plus 3 on the bottom. Can I cancel anything else? No. So my answer is going to be x minus 2 times x minus 3 over x plus 4. Somebody last period said, now do we FOIL it out? No. You are going to factor and simplify. That means leave it in its simplest form. That would be the factored form. So leave it. If you guys multiply it back together, you're going to get points off. Leave it factored. And that's all we're doing today. We're going to factor a whole bunch and cross out. So again, attack the problem the same way every time. I'm going to say, what is the sign in between these two rationals? Multiplication. That means I have to do what? I got to factor and then cancel out. I don't have to keep, change, flip or anything. So x squared minus 9. Can I factor that? X plus 3. And what? X minus 3. Good. Okay, that's gone. I'm not going to look at it anymore. X plus 3, I'm just going to put in parentheses. X minus 3 in parentheses. X plus 4 in parentheses. Now, anything on top and bottom, we can cancel. I have an x plus 3 on the top and an x plus 3 on the bottom. I have an x minus 3 on top and an x minus 3 on the bottom. What am I left with? That's your answer, x plus 4. Sometimes you guys will have a big problem where you're factoring all 4 parts and everything cancels out. Don't think you did something wrong. That absolutely could happen. Absolutely, that everything could cancel out. Have a 1 left over. Okay, so look at number 3. Again, I'm going to take it in pieces. We are multiplying, so I know I have to just factor each piece. So let's look at the top left. Again, factor how you want to, if you want to do grouping or if you want to do it my way, I don't care. But factors of 2 times negative 6 is negative 12. So factors of negative 12 that multiply to give you a negative 12 but adds to give you a positive 1. Okay, so x plus 4, x minus 3. Since my a term is not 1, I have to divide both of these by 2, correct? So I'm left with x plus 2, and then what is my second parenthesis? 2x minus 3, okay? 2x minus 3. And then I like to tell myself, okay, I already dealt with that one. I don't have to look at it anymore. Now you guys can go to the right or you can go to the bottom. I don't care. I'm just going to go down to the bottom. Factors of negative 5 that multiply to give me negative 5, but add to give me 4. X. I agree with 5 and 1. What are the signs? Negative 1, positive 5. Because when we add, we want that 4 to be positive. Okay, good. Got that taken care of. So now I'm going to go to the bottom right. What's the GCF of 4x squared minus 6x? 2x. Okay, so if I divide out a 2x, what am I left with? 2x minus 3. Perfect. Now let's go to the top right. What's the GCF that I take out first? X. Okay. Then I have x squared minus 3x plus 2. Can I factor that more? Are there factors of positive 2 that multiply to give me 2 but add to give me a negative 3? Perfect. X minus 2 and x minus 1. Now, all we just did there, guys, was 4 factoring problems. That's it. 4 factoring problems. And now, anything that is exactly the same on the top and the bottom, we can cancel out. So take your time. I see a 2x minus 3 and a 2x minus 3, yeah? Okay, what else? An x minus 1 and an x minus 1, good. Anything else? Nothing else? There's 1x here and 1x here that I can cancel out. So what are we left with? There was an x on the top and then a 2x on the bottom, so you can cross out the x's. So you have x plus 2 times x minus 2 all over 2 times x plus 5. I'm not sure where that x went there. No idea. Wait, hold on. X. This is an x minus 1 here. And this was an x minus 1 here.
Wait, where did you get the 2 from?
Right here. This had x over 2x.
Yeah, cancel.
So your x's cancel, and then your 2 stays.
I thought it was, like to the power. No, like in my mind.
You're fine. Here, let me rewrite it. Hold on. So in our factored form, Brienne, we had x plus 2, and then this was x, 2x, right? 2x minus 3. Okay, then on the bottom we had x minus 1 and x plus 5. Then over here we had x minus 2, x minus 1. And then on the bottom we had 2x times 2x minus 3. So our x minus 1 and x minus 1 canceled. There was an x there, right? So then 2x minus 3 canceled with 2x minus 3. And then I have an x here and an x here that just cancels. So that's where that 2 came from. We've got to make sure we stay super organized, guys. All right, let's look at number 4. I'm going to put my x minus 1s in parentheses just so I remember that they are stuck together. This is a multiplication problem. Is there anything we need to factor? No, everything's already factored for us. So what is exactly the same on the top and the bottom? Okay. 5 goes into 5 how many times? Once. And 5 goes into 25 how many times? 5. Good. What else can I cancel?
The x minus 1.
The x minus 1 and the x minus 1. Guys, what is left in your numerator? A 1. It does not just go away. There is a 1 left there. And then what's left in your denominator? 5 times x minus 2. Good. Good, good, good. Okay, moving along. Again, we're going to factor. We notice it's a multiplication problem, so we're going to factor first. I'm going to factor my top left numerator. Factors of -6 that multiply to give me -6, but add to give me a -1. -3 and +2. Okay. Now I'm going to go to the denominator. Factors of 9 that multiply to give me 9 and add to give me 6. X plus 3, x plus 3. Okay. Now this x plus 3 just stays. And then what does x squared minus 4 become? X plus 2 and x minus 2. Okay. Now that you have everything factored, anything that's on the top and the bottom that is exactly the same, we can cancel. So I have an x minus 3 here and an x minus 3 here, correct? No. That just looks like a 3 because I have bad handwriting. This is a 2. This is a 2. Okay, so x plus 3, x plus 3. 1 here, 1 here. What else? I have an x plus 2 and an x plus 2. Anything else? Yes or no? No. Okay, so my numerator is x minus 3. And what's my denominator? X plus 3 and x minus 2. You guys are going to stay super, super organized. Thank you. Watch your signs. Take your time. All right, how does 6 change a little bit? It's division. Do not factor first. What should you do first? Keep, change, flip. If you forget that step, guys, the whole problem is going to be wrong. So keep, I have x cubed minus 8 over x squared minus 4. I know some of you are like, it's x plus 2, x minus 2. Just wait a second. I'm going to change my division sign to multiplication, and then I'm going to flip. So x cubed, God bless you, plus 8 over x squared plus 2x plus 4. And now we're going to factor. Top left, guys. Is that the difference of squares? No. Is it the difference of cubes? Yes. So my a term is x. My b term is 2. What does my first parenthesis look like in my difference of cubes? Perfect. X minus 2. What does my second parenthesis say? X squared plus 2x plus 4. Good. All right, now I'm going to go to the bottom of that fraction. What does that become? X plus 2x minus 2. Awesome. We love difference of perfect squares, don't we? All right, what happens with my x cubed plus 8? Are those cubes? Yep. So my a term is x, my b term is 2. So what does this one look like? X plus 2 and look at you guys. So great. Now bottom right. Bottom right, guys. What is that factor to? Does it factor? Okay, last period's like, it's x squared, x plus 2, x plus 2. Is it? No, guys. What's x plus 2 times x plus 2? It'd be x squared plus 4x plus 4. It's not a perfect square trinomial. So now look, what can we cancel? Is there anything on the top and bottom that is exactly the same? X minus 2, x minus 2. Okay, what else? X plus 2, x plus 2. Look at this. X squared plus 2x plus 4 and x squared plus 2x plus 4. So what are you left with? X squared minus 2x plus 4. Somebody asked me last period, well, now do I factor that? If you can, yes. But think about it, guys. This is not a perfect square trinomial. This would be x and x. This would be 2 and 2. A perfect square trinomial would take the first term, x, times the second term, times 2. That would give me 4x. Is that 4x? No, so this is your final answer. You might get to some that don't factor anymore. Don't freak out. Questions? Everybody okay? Kind of fun? A little bit? Nope. Okay, got it. This is way more fun. I'm going to tell you right now. I'm always going to be honest with you guys. This is way more fun, and this is easier than adding and subtracting. The next couple days are going to be, it's going to be a little bit of a grind, but I will pull you through it. It's okay. All right. Check out the problem. The first thing you look at, so you don't make a silly mistake and then just start to factor and cross out and then realize I did the problem wrong. What is the sign in the middle of these two rationals? Division. So that means I need to do what? I'm going to keep, change, flip. I'm going to write it up here so I have a little more room. X cubed minus 1 over x squared minus 1. Again, I know you guys see that those are patterns, but just wait a second. And then I'm going to flip. X squared plus 2x plus 1 is going to go in my numerator. And then x squared plus x plus 1 is in my denominator. So, top left numerator. That is not the difference of squares. That's the difference of what? Cubes. We already know this. So, my a term is going to be x. My b term is going to be 1. What does my first parenthesis say? X minus 1. Perfect. What does my second parenthesis say? X, whoops. Hold on. X squared plus x plus 1. Perfect. That's done. So go to that numerator to the right or the denominator to the bottom. It does not matter to me. I'm going to go down. X squared minus 1 factors into x plus 1, x minus 1. Perfect. All right, top right. Are there factors of 1, guys, that multiply to give me 1 but add to give me 2? Yeah, what are they? X plus 1, x plus 1. Good. All right, bottom right. Are there factors of 1 that multiply to give me 1 and add to give me 1? No. So that just stays as x squared plus x plus 1. Good job, good job, good job, good job. Now we look to see what is exactly the same in the numerator and the denominator. Exactly. Signs have to be the same and all that. X squared plus x plus 1 with x squared plus x plus 1. Perfect. What else? I got an x minus 1 and an x minus 1. What else? X plus 1 and x plus 1. So all of this simplifies to what? X plus 1. There is going to be a time, I guarantee you, maybe on WebAssign, maybe on a quiz, something like that, where you have this huge problem and everything cancels out and the only thing that's left over is like a -1. Don't freak out. Very rarely, if at all, will you have a problem that nothing cancels. So if you come to something like that, I would go back and check your signs because I'm sure you missed something somewhere. All right, 2 more. We're almost done. Again, this is a division problem. So before I do anything, I'm going to keep, change, and then what? Flip. X squared minus 1 and then x squared on the bottom. So let's go ahead and factor. Anything in the first fraction, can I factor anything? No. What about in the second one? Yep, x squared minus 1 is going to give me x plus 1, x minus 1, right? So what cancels? X minus 1 and x minus 1, good. And one of the x's. Do you guys see how there's 1 x in the numerator and there's 2 in the denominator? So this one's going to cancel, and then I'm going to be left with just 1 down here. So your final answer would be x plus 1 over x. You cannot cross off those x's. Don't just cross them off and say my answer is 1. Remember that in the numerator, that x is stuck with the plus 1. Super important that you guys see that. Anybody, any questions? All right, look at the last one. This one's fairly easy, but what do you have to remember to do first? Perfect. Keep. X squared minus 49. We're going to change and then flip. So top left. That's what I'm going to work on first. What is that going to factor into? X minus 7 and x minus 7. Great. Bottom left. X plus 7, x minus 7. Perfect. Top right is going to stay x plus 7. And what about the bottom right? 3 times x minus 7. All right. What crosses off? I have an x minus 7 here, and I have one here. I have an x plus 7 here and an x plus 7. What else? Another x minus 7, another x minus 7. So guys, everything in the denominator canceled. What number is still there? A 1. Everything in the bottom canceled except for the... There you go. That is totally okay to have an answer like that. Now, last period, everybody started their web assign. Some people got done, which is where you should try to get. Can we talk about something for a second? Say I have 4x minus 24 over 3 minus x. And then over here I have an x plus 3, and I have I don't know, 36, whatever. Let's talk about factoring. This one's staying x plus 3 over 36, correct? What happens with 4x minus 24? Take out a 4 and you're left with what? X minus 6, okay. What about the bottom here? Negative x plus 3. This is negative x plus 3, correct? When I rewrite this, this becomes negative x plus 3. Do you guys see that? When I would rewrite it, I would tell you to do this. Negative x minus 3, correct? Do you guys see that? Are these two things the same? No. When you rewrite negative x plus 3, that is not the same as x plus 3. If you factor out a negative, remember the negative has to stay in the problem. So obviously this becomes a 9, but your fraction is now negative. Anytime you have something that's written, quote unquote, backwards, if it's not in standard form, rewrite it and factor out that negative so you guys don't get your signs confused, so you don't get yourself confused. That make sense? Okay.